We are live.
স্যার ইউটিউব নোটিফিকেশন কোন অ্যাকাউন্টে পাঠিয়েছেন?
You can start. We are live actually.
Okay. So hi guys, very good afternoon to everyone out there. Myself Rajiv Kumar Mohanty, the Sales and Marketing Head from Dataspace Security Private Limited. To talk about our organization, it is a growing IT security company currently offering services in diverse areas of security from its India and Dubai premises and teams. DSS is a team of certified ethical hackers, penetration testers, ISO 27001 lead auditors, CISSP, ITIL professionals. We have our corporate office in Dubai, head office in Kolkata, Salt Lake IT Hub, and branch office in Guwahati. Dataspace security is growing with the aim of providing quality and impactful services. DSS identifies and addresses the grand challenges in cybersecurity and privacy. Dataspace security offers consultancy and security services in databases, clouds, websites, and portals, helps in designing next generation secure network. Dataspace Security also holds its training and educational vertical named Dataspace Academy, which provides 100 plus courses in developing solid and impactful manpower in the security and information systems as per international trends. I welcome you all for today's YouTube's live stream on live cricket score predictions using machine learning. So let me talk about Mr. Dipangsu Mukherjee, the Python and Machine Learning Analyst at Dataspace Security Private Limited. He has 4 years of experience as a statistical investigator in All India Survey on High Education (MHRD) and an experienced Python developer. He has published publications on minimum variance, unbiased estimation of reliability functions for a class of generalizations of Lindley distribution in Sage Journal. He did projects on prepared dashboard of monthly and weekly sale of an employee, interpret the results obtained through statistical analysis, market-based recommendation using NLP, WhatsApp chats analysis between two or more than two persons. He also secured 92% score in national level online quiz on statistics, secured 97% score in national level mathematics talent search. So, Mr. Dipangsu, the stage is all yours. Please start.
Am I audible?
Yes. Yes.
Good afternoon, everyone, and thank you, Rajiv and Dataspace Academy team. First of all, I will welcome all of our students for giving me the opportunity to deliver a speech on prediction of cricket scores using machine learning. So, let me first share my screen. Is my screen is visible properly?
Yes.
Okay. Now, I am Dipangsu Mukherjee, as Rajiv told. I am a machine learning analyst at Dataspace Security. Today, I will going to deliver a speech on prediction of cricket scores using machine learning, how to do it accurately or how to check the accuracy of our predictions regarding cricket scores. We will discuss the whole thing in this webinar. So let's begin. Now the two words, that is machine learning. What does this machine learning means? First of all, we'll understand about machine learning, and then we will go for Python, and after that we will do some analysis, and after that we will do our predictions cricket scores. So first of all, what is a machine learning? Machine learning means machine can learn. Machine can learn from his past experience. Like a baby learns from his childhood or from past experience. We will give some input data to our machine, and after pre-processing or after some training the model, after some evaluation of the algorithm, we will get a fruitful output of high accuracy. Accuracy may be more than 80% or 85%. That is a good model. But apart from that, that is called the machine learning. That means machine will learn from our input, from their experience. Now, one question always arises, that why we always prefer Python as a machine learning tool. So first of all, Python consists of a huge data science of machine learning library like NumPy, Pandas, Seaborn, Beautiful Soup, SciPy, etc. And also, it is very easy to write, very easy to script the code. It is very simple to use the Python as a machine learning tool. So that's why we always prefer Python other than any other languages in machine learning. Now we will understand about the types of machine learning. Machine learning mainly have three categories like supervised learning, unsupervised learning, and reinforcement learning. Now, when we have a data set and we check that if our output has a label output or non-label output, that means we have a output, there is any output or there is not any output, we will check. Based on that, we will do our partition in the machine learning. If there is a label dataset, label output dataset, then it is called as supervised learning. And if we don't have any label dataset, rather than non-label dataset output, then it is called as unsupervised machine learning. Apart from supervised learning and unsupervised learning, there is another machine learning algorithm, that is reinforcement learning. In reinforcement learning, there are some data are label output and some data are non-label output. Based on the label output, the machine will try to learn the algorithm, learn the experience, and then the machine will predict the non-label output. That's why it is called as reinforcement learning. Reinforcement learning also called as a reward punishment algorithm. When the machine gets reward, it will give us 1, and when it will get, we have a label data set, we will go for supervised learning, we know. But let me give an example so that we can understand very easily. Suppose we want to predict after 2 days what will be our temperature, and we also want to predict after 2 days the day will be rainy or not rainy. That means rain will happen or not. So there are two categories. When we will go for a continuous output, that means our temperature, which is a continuous output, we will go for our regression algorithm. And when we have a binary output, that means if there is rain or not, if the customer exits the bank or not, if there is a fraud or not in the spam mail, in the mail. So this type of problem, when we will deal about, we will go for always classification algorithm. So regression is for continuous algorithm and classification is for binary algorithm. Now, suppose our client says that please gather the data about whose age is more than 60%. 60 plus, then we will always prefer unsupervised learning because we don't have any output. So we gather our data. That means we cluster our data. So we will go for clustering in this project or in this algorithm, unsupervised. We also can do dimensionality reduction like principal component analysis or LDA, something like that. LDA we will also can do in machine learning. We always play online gaming, and we now in the market there is a self-driving car in our USA or some USA and England, London, etc. So there is always used the reinforcement learning. So reinforcement learning, self-driving vital thing. That means how machine learning works. It a pre-process algorithm wisely, evaluate the model, and lastly we will predict. First of all, it from a else primary source. But when we will collect our data from a newspaper or a journal or a government organization or a NGO, then it is called as secondary data because the data comes from second-handed. That's why it is called as secondary data, right? Now, after collection of data, we will have to pre-process our data. That is data preparation step. It is a very, very, very vital step. So, in the data, when we will get our data, we will check that if there is any categorical variables or if there is any missing variables or if there is any non value. We will have to deal all this. To deal with missing values, we will simply omit the row. That is the easiest process. But we can problem. We will go for a categorical variable function that is called getDummies. Mostly we use, and it will give us only 1 or 0. That means for MALE or M or MALE, capital MALE, anything, it will go for 1, and for female it will go for 0. So that's how we can tackle the missing value 1 or 0. That means it will categorize the variable. Now after pre-processing the data preparation, we will choose our algorithm wisely. Now how to choose our algorithm? First of all, we will look for our output, that there is any output or not. If there is no output, then we will go for clustering algorithm or unsupervised algorithm. But if there is any output, then we will check that what type of output it is. Is it a continuous output or is it a binary output? That means true or false, yes or no, etc. When we will see that it is a regression problem, we will go for regression analysis. We will go for, is it a continuous output? Yes, we will go for regression problem. But when it will be a binary problem, we will go for definitely a classification problem. That is SVM, random forest decision tree, etc. Now after choose the learning algorithm wisely, we will train our model. Naturally, we will split our whole data set into 80%, 20% or 75%, 25%. For 80% data set, this is our training data set, and based on this training data set, we will predict our test 20% data set. Now, for 75%, we will train our data set as 75%, and after that, we will test our data set in 25%. So that's how we train our model. Now, after getting a better accuracy, we will evaluate our model, and after that we will predict our output with our prediction model. This is how a machine learning workflow mainly happens. First of all, data collection, then preparation, then algorithm choice, then training our data, then evaluate the model, and then prediction our output. So this is the step-by-step process. If any step misses, then there is a severe case with the machine learning machine. Maybe his accuracy below 50%. Its accuracy below 50% or less than that. So we will have to choose the steps very accurately. Now here we are all a huge fan of cricket, and I am also a huge fan of cricket. We all know that ICC T20 Men World Cup will begin in the mid of October this year in UAE. Before that, we will have to take our responsibility to do some statistical analysis and prediction. Okay. So first of all, let's look at this picture. Here's a match is happening here uh, between West Indies and Netherlands. Chris Gayle is on the crease, and in 4.3 overs, no wicket has left on, and 66 runs have scored. And after that, we will see that the run rate is 14.67. This is a huge run rate, by the way. And on the basis of this run rate, this is our predicted score. This is not at all possible. In 50 overs, one team cannot reach such a huge score, that is 7-3-3. So the picture clearly tells us how bad is taking the run rate as a single factor to predict the final score in a limited over 50 overs. Okay. In ODI, many factors play a key role in deciding what the final score will be. Let's do some key factors, that is number of wickets left. Suppose there are 7 wickets left, and on that moment we can say that there will be a huge score by batting team, but only 3 wickets left in hand. Then we say that they will not able to get to reach a big score. Similarly, for number of balls left, this is also a key factor. Number of balls left. If there is 20 overs in the hand, then there will be a possibility of getting a big score. But if only 2 overs remaining, then they will not be able to get that much score to reach the score. Okay, and we'll take in both these cases, we will have 5 wickets in our hand. We can also take that how much scores are in current batsman batting. That means if in the striker position the batsman is in 100 plus, on the other hand, on the non-striker position the batsman is in 10 plus. So we will see that if the 100 plus run batsman will bat up to 50 overs, then it will reach a very good score. But if the batsman got out and 10 plus run batsman will come into the strike and he will reach to 50, less than 50, then we will see that there is not something like our predicted high score. Their run will be very much low. Similarly, we can obtain or relate our cofactor like how much the team had scored in last 5 overs or lost their wickets in last 5 overs. The nature of the pitch is bowling pitch or batting pitch or soft or hard, etc. And how strong is the batting and bowling team. This is all the factors we will look through. It will take our attention. Based on all the things, we will predict our score. And we will use some of these factors to predict our score using machine learning algorithm. So there is an output given. Okay. There is output given, that is total runs. We'll have to predict it, and for this we will go for a regression analysis, as it is not a binary problem or it is not a unsupervised learning problem, so we'll go for a regression analysis. Now, first of all, we will have to import our library, data science library or machine learning library like pandas, numpy. So to import the numpy library, we will write just import numpy as np, import pandas as pd, and to import matplotlib, from matplotlib we will import the pyplot. So from matplotlib import pyplot as plt and import cbond as sns. Okay. So here as np, as pt, as plt, as sns, why we did right so. When we will call the numpy library or pandas library or like that, when we call our library, we did not write the numpy or pandas. We will simply write np or pd or plt or sns. Okay. So that's why we write here import cborn as sns or import numpy as int. So this is our logic. Now we will have to import the dataset obviously. So to import the dataset, we will always use a function that is called readCSV function. And to and for from the pandas library, we always get our readCSV function. So we will write pd.readCSV variable dot inbuilt function. This is our technique, variable dot inbuilt function. And within this inbuilt function, we will simply give this is our path name where the data is located. This is our path name. And odi.csv be our data CSV file name. So path name and then our file name. And after that we'll write dataset. Is this dataset read means we will print our dataset. That's what our dataset. So dataset equal to pd.readCSV and we will print our dataset. Let's look at the dataset. Dataset consists of 15 columns and 3,50,899 rows. This is a huge row, and this is obviously we will have to consider because for huge record we will have to minimize our error. We'll have a chance to minimize our error. So this is a very good dataset. So first one is MID, match ID. This is the date. In this date, then the match has happened. This is the venue. This is the batting team. This is the bowling team. That means a match has played between England and Ireland. This is the batsman name. This is the bowler name. This is the runs, wickets, and overs. This is the ball-to-ball run. This is the now of dot 𝐃𝐚𝐭𝐚𝐿 15 column. Figure. Okay. Table dot function. It will and already be a numeric field. So this is a non-null. Here we can. It is called the disk. We all keep statistic value max on most of the matches rather than 2.9. That means 3. That means in most of the matches 3 wickets already down, and after that it will take. Okay, and maximum wickets are 10 and minimum wickets are 0. Simple like that, something like that. And similarly for total, the run will be 255 and maximum run for total is 444. Like one team has already give us the run that is 444. That is huge run. So this is the maximum run and this is the minimum run is 44. Okay. So this is the describe. So the describe gives us all the descriptive statistics about the data set. Now we will use our very potential statistical tool, that is correlation. To use this, we will use our function, that is core function, CORR core function, dataset.core. So what does correlation mean? First of all, we understand what does correlation mean. So correlation means if a variable x and if a variable y, then how they will interlink and how much strong their link. That correlation gives us. Mainly correlation lies between -1 to +1. That means it will give from -1 to +1 range. Suppose x is a variable and y is a variable. X is increasing. Similarly, y is also increasing. So we can say that they are correlated and they are positively correlated and their correlation tends to -1. But on the other hand, when we have two variables x and y, but for increasing of x, y is decreasing, then we can say that x and y also correlated, but they are negatively correlated. And their correlation is tends to -1 or 0. So that is the thing what correlation means. Now we'll see in the runs. We will take two variables, that is runs and overs. Suppose in over we know that when the over increases, our run also increases. So there must be a correlation with positive sign. So let's check. So there is the over and there is run. So their correlation is 0.93. That means it's a highly correlated. over will increases, run will also increases. When we'll check that for runs of last 5 overs, if wickets fall down drastically in the last 5 overs, then obviously runs of in the last 5 overs also not go up. So increasing of down the wickets, run also down. So increasing of wickets, run is also down. So that run is also decreasing. So the wickets in last 5 overs and our runs is last 5 overs, that is correlated, but they are negatively correlated. That is minus 0.2. That means they are negatively correlated. Increasing of wickets, decreasing of runs. That's how the other variables look like. Pretty easy things. So this is the idea behind the correlation. Now we'll do some graphs like histogram. For histogram, in the x-axis, we will always give our data, and in the y-axis, there the density function will always. So, to use the histogram or to plot the histogram, we will take our function that is called gist plot, and from this gist plot, we will take it from SNS, that means C1 library. So, SNS dot gist plot dataset in of runs last 5 overs. This is our dataset set, and based on this column, we will try to visualize our histogram diagram. Here is another parameter, that is color equal to blue, and AX level, that means x-axis name is runs in last 5 overs. So when we will execute it, we will see that X level, that means here runs in last 5 overs is already given here. So this is the X level name. This is our density function or count function, and this is our numbers. So in the matches from the data set, we see that most of the matches 20 runs happen in the last 5 overs. 20 runs happen in the last 5 overs. That's why this is the peak is normal. The peak is highest, and this is a normal curve. Okay, this is a normal curve, but this is something like left skewed curve, another thing. And if the curve is something like that, this type of curve, this is called rightly skewed curve. And for skewness equal to 0, that means the normal curve. So this type of curve will be happening. So this is the leftly skewed curve in normal. And from this, most of the runs in last 5 overs, that is 20. Most of the matches around this way. Okay, so we see that count is highest. That's why we care about that. Okay, now we will also do our histogram on the based of our total column. Okay, our total column. Here is the column name, that is the total column, and for this we can plot also histogram. So as we see that SNS.gist plot dataset, it is our dataset of total, color equal to green, and X level equal to total run. So this is our total run, this is our count or density, and this is our data. Now what we can see from this histogram, this is quite a normal graph. Okay, this is quite a normal graph with skewness equal to 0. That means no skewed happens here. Okay, most of the time the rightly filled data and left filled data are almost equal. So that's why we can say that it is a skewed free data or skewed free normal curve. So from this graph we can see that most of the matches 200 and 300 runs happen, but 250 runs and above runs happen in the most of the matches. So that's why the peak is highest here. This is why we use the histogram to predict, to assume, or to get an idea about our run, that how many runs in the most of the matches. That's why we always use our histogram. Similarly, we can use our another column, that is wickets in last 5 overs. And we can see that most of the matches, the wickets in last 5 overs is 0. This is the 0 point, this is the 0 count. Most of the matches 0 wickets fall down. That means no wicket fall down in the matches. So this is the histogram plot. And to plot the histogram, we can also use another function, that is .hist function from matplotlib. But it is easy to use the Seaborn library rather than matplotlib. But also we can see that there is a matplotlib access, so SNS comes from the matplotlib also. Okay, so when we will use our .hist function, we will simply write the dataset dot or matplt.hist, and between that we will simply give our dataset name or our dataset column name which we want to see. Now you also see a line plot of wickets in last 5 overs. Let's look closely that with the increasing of wickets fell down, the run is also drastically fell. And the runs fall down. But from the 6th and 7th wicket, the runs changed exponentially. This is a huge thing, and this is quite obvious. It's quite obvious for this. Okay. So this is the histogram and this is the line plot. And to see the line plot, we will use the line plot function from sns.lineplot. And here is the x level name and here is the y level name, that is data equal to data. Looks like, or we can generate our SNS line plot, Seaborn line plot. Now we can see about dependent and independent feature, and from here we will enter into the machine learning steps. Dependent and independent feature. This is a step starts from data pre-processing. Okay, so let's look at the data. This is our data. Only these variables or these columns affect the total score. That means runs, wickets, overs, striker run, non-striker run only affect total. So we will take our independent variable as runs, wickets, overs, striker, non-striker, and our dependent variable is total. Based on these 5 independent variables, we will try to predict our dependent variable, that is total. Okay, so we did that x and y. X is the independent variable and y is the dependent variable. When we will give the iLog function, or when we will use the iLog function, that is dataset.iLog, that means we will go for both row and column operation. Both row and column. So for row we will give just only colon, and for column we will just give in third bracket, that is 7, 8, 9, 11, 12 and 13 column, and dot values gives us the dot value. Now here one thing we'll have to understand, that Python indexing starts from 0. So this is the 0th column, 1, 2, 3, 4, 5, 6, this is the 7, 7, 8, 9 and 10, 11, 12, 13. And this is our last column, that is 14th column. So that's why it is starts from 7. So 7, 8, 9, 12, 13. And dot values gives us the value. Okay. And for dataset.ilog, for dependent variable, dataset.ilog gives us the dependent feature of the dataset, that is colon means all the rows and 14 means only the last column or the 14th column, and dot value. So this is the dependent feature, this is the independent feature, and this is the dependent feature. We will try to predict y based on our independent feature x. This is our goal. This is the goal. Now we can see easily that what is our value of x and what is our value of y. We simply use the print function. So we'll write print of x values are comma x and y values are comma y. X values are x and y values are y. Here we can see that all the values are the x, and here all the values of the y. This is the last column, 301, 301, 301, and this is the rest of the column 7, 8, 9 and 12, 13. Seventh column is runs, wickets. This column is overs, striker run, and this column gives us non-striker run. Now we will split our training data and testing data. So we will split our data into training and in the workflow we have said that. So to split the data, we will use our train test split. Our function is train test. Mostly we train our data with 80% of the data and 20% of the data is the testing data. But here we can also do 1/4, that means 25% of the test data and 75% of the training data. So we write that from sklearn.model selection. From the model selection of sklearn, we'll try to import train test split. This is our function, train test split. And we'll define some objects, that is express, ytrain, ytest, equal to train test split of x and y. Here first one is x, independent variable, and the second one is dependent variable. Here is also first one is independent variable and ytrain, ytest be the dependent variable. So based on that, we will write x and y. We will give test size equal to 0.25. That means 25% of the data is used for testing purpose, and for rest of the 75% data we will use for training purpose, and we will give some another parameter, that is random state equal to 0. Now we want to see how many columns and how many rows are there in the training xtrain, xtest, ytrain, ytest. Only we want to see that how many rows and how many columns are there. To do this, we will simply use a function that is called step function. So we'll print it, that print of row and columns of the training data set, that is xtrain dot step. That means variable dot function. We will always use variable dot function when we will deal with an inbuilt function. So xtrain dot step. Similarly, xtest dot step and ytrain dot step, ytest dot step. So after execution of the code, we will see that rows and the columns of the training dataset is 263174. This is the row number and this is the column number. Similarly, rows are for testing independent data, that means X test. This is 87725 and column number is 5. So there are 5 columns and 87,725 rows. Similarly, for training dependent data, there will be similar rows and similar rows for testing dependent data. And we will check this from dot step function. Now, we will do our most vital step, that is feature scaling of the data. Mainly, there are 2 types of feature scaling, that is normalization and standardization. In the data set, we see that our over is 0.1, 0.2, 0.3, 0.4, 0.5. This is in point, but for total, this is in a huge number with respect to that over. 0.301 is highly bigger than 0.1. So that's why we will always try to scale down all the variables into our range. So that's why we always need the feature scaling. It is also called as feature engineering. This is the main step. So to using feature scaling, we will try to import the standard scaler from sklearn.preprocess. Now there are 2 types of feature scaling, that is normalization and standardization. For standardization, we will collect our data. First of all, we fit the data for normal, mean equal to 0 and standard deviation equal to 1. That means a standard normal distribution. And we will transform our data to that non-standard normal. And for normalization, we will do min max scalar. That means it will also called as min max scalar. That means normalization equal to minimum of the data minus average of the data by minimum of the data minus maximum of the data. So that's why it is called as min max scalar. So we will try to import our standard scalar from sklearn.preprocessing, so that we write from sklearn.preprocessing import standard scalar, and we will define our object, that is SC equal to standard scalar. This is our object. And similarly, we will do xtrend equal to sc dot fit transform of the xtrend and xtest equal to sc dot transform xtest. Now, why we did fit transform and only transform? First of all, fit transform gives us, first one is fit into the normal and then it will transform. So that's why we will do it fit and transform. As we have fitted our data, then we will only need to transform our data. So that's why we will give only transform into the case. So that's why this is called a fit transform data and this is called a transform. Okay, so this is the xtrend and xtest. Now we will come into our prediction part, prediction with multiple linear regression. But first of all, we will understand about linear regression. What is linear regression means? That is simple linear regression. The equation of the simple linear regression is y equal to b0 plus b1 x1. That means x1 is the dependent variable, x1 is the independent variable, b1 is the coefficient, and b0 is the slope. Based on this event, we will predict, or we will try to predict our y, that is called dependent variable. We will evaluate our model, that is called y, is called the dependent variable. It will depend on this thing. So that's why it is called as dependent variable. It is the independent variable. To b0 something slope plus coefficient into total over, but we have many other factors are there, so we don't need to this only one factor x1. We will need also x1, x2, x2, x3, x4 up to x5. There are 5 variables we have selected. That is, these are the 5 variables we have selected. So x1, x2, x3, x4, and x5. It is the 5. Okay. So this is the simple linear regression. Now, this is the picture of the simple linear regression. This is the regression line. First of all, we scatter our data, scatter plot. This is called scatter plot, and this is our best fit line. And after doing the best fit line using the OLS method, ordinarily this square method, we'll try to minimize our error. Now, what is our error? Mean square error. What is our error? Actual value of the y is this. Suppose actual value is this, but we have tried to predict that the actual value is not this. Well, our prediction value is this. So this is the error, and we will have to minimize this error. That's how a best fit line built in the simple linear regression. This is called the mean square error, and we have to understand how to minimize our error, or how to get better accuracy in simple linear regression. That is the another part. But in this time, we will have other independent variables, that is x1, x2 up to xn, all of the independent variables, and based on that we'll try to predict our y, that is dependent variable. So this is called the multiple linear regression, because here multiple independent variables are present. So that's why it is called a multiple linear regression. Note that in the simple linear regression, here only one independent variable and only one dependent variable. So that's why we can able to plot a 2D diagram, because there are only one y value and only one independent value. For this multiple linear regression, there will be N diagram, ND diagram, and for our purpose, for our real life data, there will be 5D diagram. But we cannot afford this 5D diagram because of very much complex, very much complex, very much complex. So that's why we will always we don't need to visualize in multiple linear regression. So suppose there is a problem statement. There it is a 3D data. That means here are independent variables, two independent variables and one dependent variable. Based on that, we will plot our graph. We will plot our point in a 3D diagram in a multiple linear regression. That is the most highest diagram. This is called the 3D diagram. After that, we cannot visualize in 4D or 5D or ND. We cannot visualize. So that's why we always use in this particular data set that multiple linear regression for the particular problem statement. We don't use simple linear regression. Now to use the algorithm of multiple linear regression, first of all, we will try to import our data set that is called sklearn.linear model. From sklearn.linear model, we will import linear regression. And we define our object that is lin equal to linear regression. And after that, we fit our object into X trend and Y trend. So lin.fit, this is a fit function. With this use of fit function, we will fit our data set into X trend and Y trend. So after that, we will, after fit of the data, we will predict our data. That is lin.predict. This is our object we define linear regression. So ypred equal to lin.predict of X test. So this is our test variable, and we will try to predict on X test in our text data. And when we see our ypred, it will give us this type of result. That means 164, 192, 255 runs, 308 runs, 253 runs, etc. Now let us compare with the actual value and our prediction value, that how much it is from the actual values. We'll try to understand. In the first match, actual value, actual run is 80, but we have predicted that it is 2 times, that means 164. This is quite a huge. And for 220, the run is 192. And for 256, the run is 255. This is quite near. This is near, very much near, that 256 and 255. This is very near. And similarly for 307, 308, this is near, very much near. And this is not only the 6 values, there are 3 lakhs values. So we'll have to check our accuracy, that what is our accuracy. And to see our accuracy, we will always prefer our R-square value. Now, what is the R-square value? R-square is the statistic that will give us some information about the goodness of fit of a model. So R-square means R-square equal to 1 minus SS residual by SS total. Now what is the residual? SS residual, that means sum of the residual means summation of our yi minus yi hat, actual minus predicted value whole square, sum of this. And what is our SS total? SS total means yi minus y bar, that means actual value minus mean value whole square, and the total sum of that. And from that we will see our R-square value. In regression, R-square, coefficient of determination, it will also called as coefficient of determination, is a statistical measure of how well a regression prediction approximately the real data point. And R-square ranges between 0 to 1. That means when our R-square value is tends to 1, that means our model is very good, very good. But when our R-square is tends to 0 or near about 0, that means our R-square is very poor. That means our model is very much worst that we will ever see. And also, if R square value equal to 1, that means the regression prediction perfectly fit the data. This is a very robust case, that is R square equal to 1. Most of the in real life we don't see any R square equal to 1. We always see that R square must be lies between from 80 to 85 to sometimes it is 90. So R square equal to 1 is robust. Okay. Now to see about the R square, or to what about the R square value, we will use our score function. So this is called lim dot score. This is our object or variable. So object dot function in Elvin function we will always use. So lim dot score x test and y test. And after that, our R square value or the accuracy is 52%. That is above 50%, obviously, but not satisfied with the accuracy of the R square. In the multiple linear regression, the accuracy is 52%. That is not satisfied. We will not satisfied with this R square value. So we'll try to build another model or another algorithm that is called random forest regression. So we'll prediction of random forest regression. So as our accuracy is 52%, so that's why we will try to build another regression algorithm. Maybe random forest regression will be the R square value of the random forest regression is less than 50%. Let's check what will happen. Okay. So to understand about random forest regression, first of all, we will understand about decision tree. What does decision tree mean? And let us take an example. That's how we will understand about that. Suppose you have a job offer and the company said that you will take the offer or not based on this information. What are the informations or what are our decisions? They will say that your salary is between 50,000 to 80,000. If you are satisfied, then you will go for this split, and if you are not satisfied, you will go for this split. That is, you will simply decline the offer. If it is satisfied, then you will check that office is nearer to home or not. If office is nearer to home, then you will check that they will provide, do they provide the cab facility or not. If they provide you the cab facility, then you will surely accept the offer. That means you will take under three conditions. These three conditions obviously satisfied, and then you will accept the offer. Otherwise, you decline the offer. So this is called a decision tree. That means this is our decision. This is all our decision, and this looks like something tree. So this is called this. That's why it is called a decision tree algorithm. This is called our decision node, because from this decision we will try to minimize our conditions. That's why it is called a decision node. From this, two splits have happened there. So this is called the decision node, and these four ovals, green color ovals, are called as terminal node, because from here there is a termination. That means from here no split has happened. So that's why it is all the four are called terminal node. Now, this is about the decision tree. Now, when we will have many decision trees, then our algorithm builds with random forest. Like we all know that forest consists of many thousands, millions of trees. This is the logic behind random forest. That means here are the trees. This is one tree. This is one tree. Up to this is the 600 tree. A huge tree there is. So this all the things is called the random forest, because trees are happening here. And what is the intuition behind the random forest? Suppose this is tree 1, and from tree 1 our prediction or output is prediction 1. From tree 2 our prediction is prediction 2. Up to similarly it will go for tree 600, and our prediction is 600. Now what will happen? We will get 600 predictions. Now we will give the mean of the prediction or average of the prediction. So we'll give our average of the all prediction, and this is called the random forest prediction. This is called the random forest prediction. So this is the intuition behind a random forest algorithm. Now we will see how does the random forest regression algorithm happen. So to import the random forest regression, we will do sklearn.ensemble. From sklearn.ensemble we will import random forest regression. Now here is one decision tree, two decision tree, up to 600 decision tree. There are different types of algorithm. There are different types of decision tree algorithm. So that's why it is called, the random forest is called as ensemble section. And to define our object, that is lin random equal to random forest regression, n estimators equal to 100. N estimators equal to 100 means here we have given 100 trees, and similarly we will fit our object to x plane and y plane, and after the execution of we will huge. This is a huge. That means when we will do a multiple linear regression, we have given that our accuracy is, we have got that our accuracy is nearly 52%, but for this random forest we used our accuracy is 80%. So accuracy for random forest regression is higher than a multiple linear regression. Hence we choose the random forest algorithm to predict the max score. Now we will see one scenario. Here is a match is happening between India and Australia. Shikhar Dhawan is batting in the striker. India is in the score of 118 for 1 in 24.2 overs. And we will see our prediction, that is 118 runs is the non-striker. So KFold's run is 47 and Shikhar Dhawan is in 73. This is the first Paytm ODI between India and Australia. So after that we will predict that the projection score will be 249. This is our prediction, that the score must be in 297 or something like that, or near about that. But when we will see, it is, we will say about 24 overs. But when we see that in 43 overs the wicket falls down drastically, that is from 1 to 5, and they run from 118 to only 201 in 43 overs. And if we see our prediction, then 201, that is 201 for 5, this is 5, and 43.1, and 25 and 27, here Pant is in the striker and non-striker is Jadeja. So we will predict our prediction, that is, we will predict our score, that is 278 for 278 after 50 overs. This is our prediction. So in this accuracy, in this 80% accuracy, we see that our prediction is 278. But here we can see that our projected score here, according to their projection score is 244 after 50 overs. Now one question arises. Can we increase our accuracy more than 80%? To do this, we will have to use our hyperparametric tuning. That is called the KFold cross validation. One of the mostly used technique, that is called KFold cross validation. Now let us check what is KFold cross validation. We have all the data. Here is all the data. We will usually train our data and test our data by splitting 80% and 20%. Now in the cross validation, we don't need to split into 80-20 or 75-25. Rather than we will do some folding. We'll do some folding. For this split one, this is the 20% of the data, and rest of the 80% of the data is our training data, and based on this fold 2, fold 3, fold 4, fold 5, this type of training data set, we will try to predict our fold 1 test data. Similarly, for split 2, the fold 2 is the test data, and based on our training data, fold 1, fold 3, fold 4 and fold 5, we'll try to predict our test data, that is fold 2. From split 1, we will get an accuracy, that is accuracy 1. And from split 2, we will get an accuracy, that is accuracy 2. And from split 3, we will get an accuracy, that is accuracy 3. And from split 4, accuracy 4. And for split 5, accuracy 5. Here for split 1 is fold 1 is the test data, fold 2 is the test data for split 2, fold 3 is the test data for test 3, and fold 4 is the test data for split 4, and similarly for split 5, fold 5 is the test data. Now, what we use this algorithm? Main thing is that what we use this type of algorithm? Because here is only 80% of the data, randomly chosen 80% of the data is in training set. But for testing purpose, only 20% of the data. But here in this fold or K-fold cross validation, all the values have tested and as well as trained with our data set. So that's why it is called as K-fold cross validation. Here fold equal to 5, there are 5 folds. So that's why it is called a 5-fold cross validation. And after that accuracy, when we will get accuracy 1, 2, 3, 4, 5, we will simply use the mean of the accuracy or average of the all accuracies. That is 1 by 5 into accuracy 1 plus accuracy 2 plus accuracy 3 plus accuracy 4 plus accuracy 5. And after that, we will finally evaluate our data, or we will finally test our data set. Now we will use our data set. That is, to use our data set in K-fold cross validation, we will simply use from sklearn.model selection import cross val score. And after that, we will simply define our object, that is result cross val score. And after that, we will give the lim random, that means our object, and x value, y value, and CB equal to 10 means cross validation fold equal to 10. That means we have done 10 folds here. In this data set, regarding our data set, we have done 10 folds here. And the result consists of result 1, result 2 up to result 10 values with accuracies. Result 10 accuracies. So that we will define lin equal to np.mean. Np means numpy. We have told that numpy in previous. So numpy.mean. There is a function mean. So np.mean result. That means all the 10 results will be getting at average or mean of the value. And we will store it in lin. So let's check our accuracy, and we will see that accuracy is 87%. This is a huge accuracy. That means our model will predict almost the right of the data. This is a huge accuracy, 87%. Now similarly, we will apply our result to our random forest regression, and similarly we will try to predict our score. Now, so results equal to, this is the results equal to random forest regression. In estimators we have given 10, 100 trees, and after that we will fit our result into train and test. And similarly, new prediction equal to results.predict sc.transform np.array. This is our 2015. Let's check once again. 2015 15 43.1 25 27 43.1 25 27. This is the run, this is the wicket, this is the overs, this is the striker run, and this is the non-striker run. And we will convert it into an array, that is np.array, and we will similarly transform this with our standard scalar, and we will predict our result. And when we will predict our result, we store it in a new prediction. And after that, we will predict our score, that is predict our score is 259.29. 259.29 our predicted score after 50 overs. So in this match between India and Australia, in 24 overs, the run is 11841, but for 43 overs their run is 201.5. The run also goes very much down, and also the wickets have fallen drastically. So that's why you can see that the partnership is 27 runs in 53 balls. Huge balls, but 27 runs only. That's why the of this match, what will India score in final match? So let us check what is this final score. This is 255, and we have predicted that the match run is 259, just almost within the million 3 lakhs data. Within the 3 lakhs data, we have tried to predict our prediction, that is 259. This is a huge thing with the accuracy of 87%. Most of the 87% times it will predict our output right. It will not accurately 255. We cannot do this because for this we'll have to do R square equal to 1, and I have told that this is a robust model. In real life this cannot be happen, but 87% accuracy is far better, is very much better, and we will accept our algorithm, that is random forest regression, and also K-fold cross validation, and our final score is 255 in 49.1 over 5 balls remaining there. Also maybe in 5 balls there will be on again 4 runs will be added, so 259 maybe, not sure, maybe. So that's why we'll predict our score using our machine learning algorithm. 259.29, that means 259 is our final predicted score. So that's how we will always predict our score. You can always predict your score in upcoming T20 matches, in men's T20 World Cup. You can also do some analysis regarding that, but I hope this is all about the thing. It's all about the webinar, and thank you for your attention. Thank you.